All right, so here's my memory manager header file. So we can see we have like essentially we're doing like a linked list where a doubly linked list where each node is a block that records if it's free or not, and then the size. And then we can navigate from that block to all of the rest of the blocks just by traversing through our list. So what we're doing for holes is a hole is just one of these blocks that has this allocation. I mean, it's is free either it's free, and if it's is free, then it's a whole, and then if it's not free, then it's like being used, right? So that's essentially how we are doing that. So we can go to the look at the initialization. Uh, Initialization at the top here, yeah. So we're using mmap here. Um, yeah, so for mmap, what I did here is use map anonymous to create anonymous memory mapping. And then I looked up that we got to get to the read write permissions here with this here, and then the map private makes it process private. So this was done for like the extra credit. And then we can go look at the allocate. So for allocate, we are just like converting bytes to words. And I have like a method for that called bytes to words, which we see being used here. And then we're using get list to basically traverse the whole linked list and just like get us all of the free blocks, which are our holes. Free blocks are holes. So after we have like a selected hole, like via this allocator, which is just uses like whatever algorithm we're using to like find the hole that we want to place it in. Then we split. We do the logic where we like split it if it's larger than needed, and then we allocate it. Now, if we go to free, if we look at free, we see we're going to be calling merge adjacent, which is like a adjacent blocks, which is a method that is going to take the next block and the previous block and merge these so that we don't have like any fragmentation going on. Um, yeah, it's just getting like the adjacent blocks, marking it as free in the free function, and then let's go to get list. Oh, where is get list? So I guess we just have a dump memory map. So dump memory map here. Essentially, we're doing our like read and write our IO stuff using POSIX calls. Like we got open here, we got write down here. It's also using get list to get all of like the holes. And here's the get list function. It's really simple. We're just iterating through our list and getting all of the holes. Now we have our bitmap. And essentially what we do here is we just like note that a zero is going to be free and then one is going to be allocated. And then what we do for our allocation algorithms that I was talking about, we can find one. Let me search best best fit. Yeah, so the best fit, what this one's gonna do, it just finds the smallest hole, and then the worst fit finds the largest hole. Um, And that's pretty much it. That was the algorithm that runs based on whatever allocator we choose. So now let me do and the commands to show that this is working with make clean, make, and you can see in the side like what it was doing, like the file system. Then we do the make, and then I have this command copy, and after that we run the test runner. Yup, 38 out of 38. You can see all the things passing here. And then I think we also run with Valgrind. I think I have that saved here. Yeah, yeah, we can run it here with Valgrind. Um, yep, pretty quick. And we can see we have zero errors here, which is good stuff. All heap blocks were freed. So it looks like we don't have any memory leaks here. Um, yep. So it looks solution works. That's pretty much it. Um, Yeah. So that's how my implementation works. Thanks for watching.